Supply duct system. Supply duct system. The two most common supply duct systems are the extended plenum system and the radial system. The other options are spider and perimeter loop. So yan yung style ng mga ducting. Ito yung extended plenum, isang size lang ng duct, tapos marami siyang branches. Maximum is 24 feet allowed. Extended plenum system. In the extended plenum system, a large main supply trunk of equal size is connected directly to the air handler. The smaller branch duct and runouts are connected to the trunk. The arrangement provides airflows that are easily balanced and can be easily designed to be located inside the conditioned space of the building. The principal design limitation of the extended plenum is the maximum length of the main supply tank of single size, which is usually limited to about 24 feet. When this length is exceeded, pressure tends to build up toward the end of the duct, resulting in too much airflow near the end and insufficient airflow in branches closer to the air handler. So, however, the extended plenum system can be modified to provide a double span, so up to 48 feet long, when the equipment is centrally located. So, see the figure. So, yan. Extended plenum system, double plenum. So, minsan may gumagawa niyan. So, kaya lang yung velocity, dapat ma-check mo kung ano pa rin. Pasok sa limit, minimum. Kasi kung hindi, tutulog na yan. Kung aircon yan. May stuck yung hangin, so yung condensation, may stuck din. So general rules, the following general rules apply for the extended plenum system. The single plenum should not exceed 24 feet in length. Double plenum should not exceed 48 feet in total length. Keep branch run starting collars 24-inch from the end cap. Never locate a takeoff in the end cap. So huwag ka magdudugtong dito. Okay. Reducing plenum. So ito naman ang every 24 feet so pag-reduce ka. The reducing plenum duct system can be used when the physical layout of the space called for greater distances than length constraint imposed on the extended plenum 24 feet. The concept of the reducing plenum is simple. When the air velocity lost to the branch reaches approximately 50%, the plenum size is reduced to regain the velocity in the remaining portion of the plenum. So, yan. This reduction improves the airflow characteristic at the branch duct that are closest to the air handling unit. Another variation of the system is the reduced trunk system described in the next slide. So this is not the reducing trunk system. This is the common, matipid sa materials, matrabaho lang. Pero ito yung talagang standard design. Kasi yung velocity, tama. At yung friction loss, na-maximize niya. Okay. Yung design value, so maliit yung duct mo. Next, materials. So the reducing trunk system is very similar to the reducing plenum system, with the exception that the trunk plan is reduced in size after each branch takeoff. The reducing trunk system reduces the cross-sectional area of the trunk periodically after every branch or run out. The arrangement maintains a more uniform pressure and air velocity in the trunk, which improves airflow in branches and run out closer to the air handler. The system is well balanced since each branch is specially engineered. So may mga damper pa yan. Effective design of reducing trunk system requires precise determination of supply air or extract air quantities for each terminal device, diffuser, register, and wheel in the room. The figure illustrates the concept. Obviously, this type of system generally takes more sheet metal to build and require more labor to fabricate and install. More level kasi marami siyang reducing. So a spider system is a more distinct variation of the trunk and branch system. Large supply trunk, usually large diameter flexible duct, connect remote mixing boxes to a small central supply plenum. The smaller branch duct or run out take air from the remote mixing boxes to the individual supply outlet. So the figure to sa right illustrate the concept. Ito yung spider duct system. Yung unit mo. Tapos plenum. Then, connect naman doon. Then, pagdating doon, top naman. Yan. Tawag yan spider system. Next, the radial system. So in radial system, there is no trunk duct, branch ducts, or runouts. Rather, individually supply outlets are essentially connected directly to the air handle, usually using a small supply plenum. The short direct duct runs maximize airflow. The radial system commonly is applied in attics, crawl spaces, and in slab on grade installation with the ducts embedded in the slab. It can be used with upflow, downflow, or horizontal air handler and furnaces. Traditionally, this system is associated with an air handler that is centrally located so that the ducts are arranged in radial pattern. However, symmetry is not mandatory. In design, using parallel runout can be designed so that duct runs remain in a conditioned space that is installed above drop ceiling. Perimeter loop. Sa figure, di ba? Ito yung perimeter loop. Siyempre, kailangan mo ng supply dyan. So, a perimeter loop system uses a perimeter duct feed from a central supply plenum using several feeder ducts. This system is typically limited to facilities built on slab in cold climates. Okay, rules of duct design, which is from ACA Manual D, residential duct system. So up to 24 feet of trunk length, use one size. Over 24 feet, reduce trunk size every 15 feet to 20 feet. Use tapered reducer for trunk reduction on cap trunk. Standard trunk is 8 inches high, minimum. Trunk width not to exceed trunk height by more than 4 times. Use offset take-offs rather than straight take-off. Stagger the branch take-off. Damper its run as close to the trunk as possible. Neither branch off any closer than 12 inches to the end or nor of the end of the trunk. No take-off 4 feet after deduction or 1.5 times the greater dimension of the duct. Never take off a reduction or increase the mains any closer than the diameter of the branch duct. On supply and return, when the trunk is wider than the plenum, a transition fitting must be used. Okay. Residential. Next, return duct system. So air conditioning system not only supply airflow to rooms, but they pull air out of the room also. If the return flow is not free to exit this space, the pressure will build up in the room and the lost air must be replaced. This causes increased quantities of outside air, which can bring additional heat, humidity, and other undesirable elements with heat. The supply air must therefore be balanced to maintain neutral fresh air pressure within space. This is done by designing ductwork with an adequate number of return duct or gills. Return duct systems are generally classified as either central or distributed return. Distributed return, so in a distributed return, each room has a return duct that provides a pathway for air to flow back to the air handler. This scheme ensures that the airflow is returned from all room, avoid too much positive pressurization, minimizes pressure imbalances, improper privacy, and is quiet. However, design and installation costs are generally higher than for a central return system, and higher pressure losses can increase lower requirements. Now, For central return, in a central return duct system, return grills are located in central location on the common plenum, usually close to the air handle. To ensure proper airflow from all rooms, especially when doors are closed, transfer grills or jumper duct must be installed in each room. Yan, tama, transfer duct para lumipat yung hangin. Central return duct should have at least 90 degrees bend between the air handle unit and the central return grill. And the airspeed at the face of the return gear should be designed at 350. This keeps noise in check while allowing enough negative pressure in the return box to draw in outside air with the central fan integrated supply ventilation system. To size the return gear, use the equation below and divide the result by 0.65 to account for 65% per area, which is normal for stamp return gear. So ito yung equation. Area is equal to Q over B, where A is equal to area in square feet, B is equal to airspeed in feet per minute, Q is the volumetric airflow, CFM. Now, central return duct system offer the following advantages. So, they require less ductwork than a distributed system. They lower energy loss since larger plenum space provides a more direct path for airflow. They reduce installation time and cost of material. Yeah. So, wait, tatatog dito. So, for the pressure balancing, the return opening will need to be 2 to 3 times the size of the supply duct. Yan. Depending on the system design velocity. This can take the form of transfer wheel and jump duct. A, transfer wheel. So, nakikita niya yan. Transfer wheel. Ito, door wheel yan, pinto. Transfer wheel, sadya kang butas dun sa wall. Yung supply duct, so, ang supply mo nasa lalim. Ito naman transfer gear kasi walang aircon dito. Ito yung supply mo. Lipat siya doon. Tapos yung return, punta na doon sa unit. So they allow air to move from one space to another to alleviate pressure difference. For example, a transfer gear installed above a bedroom door enable air to move between the bedroom and the hallway, regardless of whether the door is open or closed. Door undercutting can help as well. For example, 3/4 inch undercut of a 32 inches door will create 24 square inches open area, but isn't normally sufficient on its own. A transfer gill and or jump duct are often required to equalize pressure and prevent overpressurization of the spaces. A rule of thumb, consider 1 square inch of wall opening per CFM delivered to the room. So, yan. Ito ang mga solusyon. So, hindi naman ito nangyayari sa atin kasi nga maraming kumukontra. Ayaw pabutasan. So, kaya saka uso dito yung free blow o split type. So, pag ducted, so ganyan ang mga design. So, minsan ayaw kasi yung additional cost. Pero, mas efficient. So, jump duct. They are short duct that connect adjacent room and help balance airflow between room in cases where there one shared return gear serving the whole floor. As a general rule, no room will have less than 6 inches diameter jump duct, and if more than 250 cm needs to be transferred back to the main return area, it may be advisable to run a dedicated return duct to that area instead. So this is for 250 cm. For more than dyan, malaki na. So kailangan mo na magbalik sa dedicated. Balik sa ducting talaga diretso na to. So hindi pala pwede. So, pang maliit lang na room. So duct fittings and terminal units. So duct fittings and transition. So dito yung example ng mga elbow at branching. So duct losses occurs across fitting and transition. While SMACNA standard are almost always the guiding document for construction, experience has shown that proper techniques are not always followed during fabrication and installation. Design engineers often do not allow sufficient room to install proper and size transition or offset. Often, during installation, there is insufficient room and the fittings are squeezed into tighter spaces. Good engineering practices include unless a reduction of 2 inches can be made, the original duct size should be maintained. Then, the slope of transition shall be 8 degrees to a maximum of 14 degrees. When the duct area is increased, the slope is not to exceed 8 degrees. Use reduced elbow rather than square elbow whenever space allow. So, when a full reduced elbow cannot fit, a part reduced elbow or square elbow with one or more splitter should be used. Turning vane should only be used on low velocity system where reduced elbow will not reach. So, andito yung mga good practice. So, ito yung best elbow. Good, lagyan mo lang siya ng turning vane. Ito, cross to. Cross. So, yan. Lagyan mo ng ito. So, ito naman yung best niya. 45 degrees. Radius entry fitting with no turning vane result and very low pressure down. Okay. So next, volume control damper. Dalawa yan. Meron opposed blade and parallel blade. So dampers are used to control airflow. They may be required to fully shut off airflow or regular flow. Two main types are in use: the parallel blades where the blades rotate in one direction or opposed blade where the adjacent blade rotates in opposite direction. So pressure loss across the damper and leakage through a closed damper are two performance criteria affecting the selection of damper. Parallel blade damper are best suited for full open or closed requirement or fine control between 80 to 100% full flow. Opposed blade damper are best for system where air volume is changed over a wide range. Ayan ang pagkaiba niya. AMCA recommends using an opposed blade damper when volume control is needed. Common yung opposed blade. Next, the balancing volume adjusting damper should be installed close to the main supply as far away as possible from the outlet. Terminal dampers such as those used in register and diffusers should not be considered in branch balancing as they are meant to be used for fine adjustment only and would normally be in almost a fully open position to prevent unnecessary noise. Yung mga grease na yan, yung mga diffuser, may damper na yan pero hindi yan kinoconsider na pang balance. Pag bumili ka ng unit na damper, diffuser, meron siya. Ang open close lang yun. Fire and smoke damper. So fire and smoke damper. The device installed in lock and air transfer opening to interrupt the passage of flame and maintain the integrity of fire rated separation. Fire dampers are equipped with a fusible link rated for 165 Fahrenheit up to 286. Ayan, ito yung fire damper, smoke damper, and combination fire smoke damper. Ayan, fusible link that holds the blade open until the links melt. Upon reaching the melting point, the blades then close and stop the flame from moving into an adjoining compartment sa salayan. Location. Fire dampers are being installed in or near the wall or floor at the point of duct penetration to retain the integrity and fire rating of a wall or floor whether it is ducted or open plenum return application. Single duct. Should the ductwork fall away, the damper needs to stay in the wall or floor to maintain the integrity of the wall or floor. One should actually think of the fire damper as part of the wall itself. Smoke damper are defined as a device designed to resist the passage of smoke through the HVAC system, hindi papasok doon, or from one side of fire rated separation to the other. Location, they must be installed no more than 24 inches from the smoke barrier. Of course, smoke dampers that are used to isolate air handler are not limited to this distance requirement. And if PA 98 states that the smoke damper are to be used to isolate air handling units over 15,000 CFM. So, kailangan mo na ng smoke damper. Diffusers, grills, and registers. So, andito yan. Diffuser, grills, and so nawawala yung register. So, supply grill. Return grill, keyboard diffuser. So, ang register, open lang yan. So, diffuser are, okay, basta mo nang pwede isang register. So, diffusers are the terminal devices that supply air in various directions through the use of their deflecting vanes. These are designed to promote the mixing of conditioned air with the air already in the space. Grills are defined as air devices that are typically used to return air back to the fan or to exhaust air from the space. Grills are generally not used in supply distribution due to their inability to control the air. So, hindi pwedeng gamitin as supply air grill. So, meron tayong registers looks like grills but are comprised of one-way or two-way adjustable airstream deflector. Ayan, tama. And dampers to restrict the amount of airflow required to be returned, supplied, or exhausted. So, ito yung itsura ng register. Grills, ano lang siya? Opening lang. Ito, may upo yan. May crossing. Steps for selecting air terminal. A. Determine the airflow requirement and room size. B. Select the appropriate diffuser. C. Determine the velocity, throw, noise, and pressure drop across the diffuser. Sa air conditioning natin, discuss din yung velocity, throw, noise criteria. Okay. Let's check the characteristic of the diffuser, item C, with a help of an example. Table below provide performance condition of a typical diffuser. So for a velocity, dito is 400, 500, 600, 700, 1,000. Ang pressure drop niya is ito, 0.056 to 0.355. Noise is 14, 20, 24, and 38. Throw is 5, 8, 13, 7, 9, 30 yung average. Yan. Feet. Throw is discussed as the, pag sa diffuser, this is the vertical height. Height niya, di ba? Height sa yung characteristic length. So, balik tayo doon sa air conditioning na din-discuss natin. So, ito. Air velocity, it is the normal air velocity used for comfortable distribution as is 50 feet per minute while the acceptable range is from 25 to 75 feet per minute. This is the most comfortable air doon sa, ito yung dito ka, dapat 50 feet per minute. Andyan, pinakalas mo is 50. 150 feet per minute, 100, so length at 50. So yan ang dapat mama sa'yo o sa mesa mo. Kasi kung hindi, nasa 150 ka, lumampas ka dyan, lilipad rin yung papel mo. Dito sa office, nag-aircon ka, ang lakas, doon lilipad yung mga papel mo. Ang tama lang is 50 feet per minute. So pressure drop, it is the pressure drop across the diffuser increases at higher velocity. Nice criteria, NC. NC increases at higher velocity. If a typical space requires an NC rating of 28 to 32. So, yun. Noise criteria, NC increases at higher velocity. A typical space requires an NC rating of 28 to 32. True. Through is defined as the horizontal distance from a diffuser at a specified velocity. For example, through at 50 is 15 feet, indicates that at a distance of 15 feet from the diffuser, the velocity of air will be 50 feet per minute. Then T100 is 10 feet, indicates that the distance at which the air velocity is 100 feet per minute. And T150 is 5 feet, indicates distance for 150 feet per minute. Oftentimes, throw is shown simply in the following format: TP150, T100, and T50. Parang ito. Yan. Throw. 7, 9, 12. Limbawa. Yan. Diba? 7, 9, 12. So, for example, in the table above, so ito nga, a velocity of 100 feet per minute at 9 feet from the diffuser and a velocity of 50 feet at 12 feet per minute at 12 feet from the diffuser. Okay? Next. Okay. Location of air inlet and outlet. A supply diffuser is responsible for most of the air movement within a room. As supply air leaves a supply register, it has a certain volume of flow rate expressed in CFM. That is the primary air. As soon as this air leaves the outlet, it begins to attract secondary air already existing in the room. This room air joins the primary air and is carried along with it. The moving air stream has now a much greater volume by the time it reaches the end of its straw. The total volume divided by the primary air volume is called the aspiration ratio. A high aspiration ratio is good because it means that a greater quantity of air is kept in motion, with less chance of stagnation in parts of the room and with less chance of temperature stratification within the room. Diba? Ang aspiration, yung mahalo. So kaya mostly, i-design yung supply diffuser, ang velocity niya mas mataas kaysa dun sa return wheel. Bakit? Para yung hangin mo tumagal dun sa loob, di ba? So, mabagal yung speed niya yung palabas. So, nai-stuck na sa loob, nakakapag-circulate pa siya. Yan. Kaya mas mababa ang velocity nun. Kung nasa 500 feet per minute ka, gawin mo 400 yung return. So the following key point should be noted. So A, locate diffuser so that the T50 length is nearly equivalent to the characteristic length, which is defined as the distance between the center line of the diffuser and the wall, or the distance between the center line of the diffuser. Ayan. So, yan ang magiging spacing mo. So, ganito ng iba, basta sa tinatantad ng diffuser. Kaya hindi na bumababa yung hangin. Kasi nga, masyado ng mabagal. Dapat tama lang ang bilang ng diffuser mo. Tapos, para yung area, para yung throw mo malakas. At hindi naman sobrang lakas. Tamang-tama lang sa 50 feet per second. Okay? Kaya yung iba, tinatamba lang. Tinatantad pa ng diffuser para mas malamig daw. Dadagdagan pa nila ng outlet. Kasi yung aircon mo, hindi naman nag-increase ng flow rate. So, mag-increase man yung dadagan pa ng flow rate yun, yung cooling capacity mo, hindi rin nagdagdag. So, sabihin, mas lalong uminit. Okay? When cooling is the dominant space conditioning, install ceiling diffuser or high wall outlet that discharge air parallel to the ceiling. See, a return air inlet that is located directly in the primary air stream of the outlet of the supply outlet where short circuit the supply air back into the return without mixing with room air. Place the return high when cooling is the dominant factor and low when heating is the dominant factor. So, sabihin, nasa taas, huwag mo siyang itatabi doon sa outlet, supply. Kasi hindi na siya mag-circulate. Kahit anong compute mo pa, pagdag mo ng aircon sa load yan, hindi talaga lalamig yan kasi hindi nga pumapasok. D. Special situations that require careful attention by the designer are relocation of return and exhaust inlets in the bars, kitchen, laboratories, dining room, club rooms, etc. These normally should be located near or at the ceiling level to collect the warm air build-up, odors, smoke, and fumes. Duct fittings pa rin yan. Okay? So duct construction, and reinforcement. So duct construction, yung paggawa nitong duct, ito yung tinatawag ng mga reinforcement. Ito, trans to. Ang reinforcement niya pala ito. Okay? Ang mga joints, pag joints to. Okay. So may reinforcement dyan. Minsan naka-ano sa, ayan, may stiffener. Yan. The Sheet Metal and Air Conditioning Contractors National Association, SMACNA, defines the duct construction standard for rectangular, round, and oval ductwork for positive or negative pressure classes up to 10 inches water column. This duct construction standard allow an estimator to specify what gauges, connection, reinforcing, and tie rod are to be used for rectangular, round, and oval ducts. Lahat. Diba? Ano kayo sa site? Pinano sa yung mga materials na gagamitin. So, alam mo yung mga materials na ito, yung mga materials. Duct construction. Duct walls, transverse joints, longitudinal seam, and reinforcement at or between joints make up the basic element of duct construction. Its size and pressure class has a minimum duct wall thickness and a minimum specification for joints and reinforcement. The details are available in SMACNA 3rd edition 2005 guys. Ano kayo ng download yan? SMACNA duct construction. So duct sheet metal thickness. The galvanized sheet metal is a common material for ductwork. The sheet metal thickness is specified in gauge, and the greater of the duct dimension determines the sheet thickness gauge. The table below on the right provides the general guidelines. Refer to SMACNA guide for more realistic thicknesses based on operating pressure. Note that the lower the gauge, the thicker is the sheet metal. So rectangular, column duct. So, ito yung greater dimension niya, rectangular up to 30 inches, gauge 24. So, yung equivalent mm niya, hanapin niya lang dyan sa internet, pero ano yan eh, equivalent. O dun sa SMACNA. Ilang mm yan. Okay? So, aluminum gauge, ayan, 31 to 60 inches, 22. This is general lang, general. Okay? So, in inch, ito naman. Up to 8 inches the round duct, 24 gauge, aluminum gauge 22. Okay? Ang kabisado ko dito itong 16. Gauge 16. Gauge 16 is 1/16 inch or 1.6 mm. Diba? Naritandaan yan. The galvanized sheet metal recommended for ductwork should have a zinc coating at least 1.25 ounce, 35.4 grams per square foot on both sides of the sheet and should be of lock forming quality. Malambot. The weight of galvanized steel is as follows. The 24 gauge is 1.156 pounds per square foot. Console, gauge 22, gauge 20, and gauge 18. Andyan yung mga weight niya. Bakit kailangan mang-weight? Pag nakuha mo yung weight kasi merong ang price niya per kilo. O, kung meron kang per sheet, i-convert mo sa per kilo, madali na. Aspect ratio. Saka itong weight na to, kailangan mo to sa hanger. Aspect ratio is an important factor to classify cost and airflow effectiveness of a rectangular duct. The aspect ratio is the relationship between the width and the height of a duct expressed as a ratio width over height. Increasing the aspect ratio increases both the installed cost and operating cost of the system. A rectangular duct with an aspect ratio closer to 1 will use the lowest sheet metal. Other benefits include low friction drop, low weight of metal, and lower insulation and installation cost. So example, a duct with a cross-sectional area of 4 square feet and 100 feet can be fabricated as 2 by 2 or 1 by 4 dimension. In the first case, 2 by 2, the perimeter 8 feet. The total sheet metal required is 8 times 100 or 800 square feet. In the second case, the 1 by 4, the perimeter 10 feet. The total sheet metal required is 10 by 10, 100 is 100 square feet. So as the aspect ratio increases from 1:1 to 1:4, the surface area and insulation requirement increases 40%. So duct fabrication and length. Ito yung duct construction, pour and metal. Kasi ito, walang 45 degrees dito. Ha? Ginawa splitter. So, hindi maganda yung flow niya. Ito pa. Yan. Straight standard length duct cost less since duct machine, such as coil line for rectangular duct, automatically produce duct sections of usually 5 feet long. Yung mga pre-pop. Any rectangular duct that is not a standard length is technically a fitting since it cannot be made by the coil line. While a spiral round duct can virtually be of any length, it is commonly cut to 20 feet section to fit into a standard track. Yung track, kung deliver mo. Diba? Oval duct standard length vary depending on the fabricator, but manufactured duct are typically 12 feet long. It is not uncommon for an experienced designer to include too many duct size reduction with the false impression that reducing duct sizes will reduce cost. Yan. Ito, kung maliit lang naman, kaya nga nag-even number tayo. Kasi kung dito, 42 by 16, ang totoo niyan, ito, 42 by 16, ito, 42 by 15. So, magdadalawa ka, 42 by 16 mo na lang. Oh, di ba? Kasi maraming maliliit na, no, na nagiging size mo, isa lang. Okay? Lalo na pag ito, dalawa. Dito mo, 42 by 16, pero dito, 42 by 14. So, gawin mo na by 16. Ito, hindi mo na pwedeng gawing area diretso na 42 by 60 kasi masyado nang mabagal yung hangin. Okay? So, duct hanger spacing. So, meron na yung insert dito na hanger. So, duct hanger spacing. So, cross-sectional perimeter of duct. So, maximum hanger. Horizontal duct less than 4 feet. Maximum is 8 feet. Horizontal duct 4 feet to 10 feet is 6 feet ang spacing. The horizontal duct greater than 10 feet is 4 feet. So, this is cross-sectional perimeter of duct. Perimeter. Now, good engineering practices. Energy conservation. Typical duct system lose 25 to 40% of the heating or cooling energy. So building with ducts in a protected area such as basement may lose somewhat less than this, while some other types of systems such as attic ducts in hot, humid climate often lose more. So duct system lose energy in two ways. A. The first way is via heat transfer from the duct wall. Ducts in a conditioned space are the most energy efficient. Kasi konti lang ang yung difference ng uh, temperature ng duct saka sa room. Ducts running through unconditioned spaces like an attic or crawl space should be insulated. Heat gains and losses are minimized and go directly to the conditioned space. B. Second is via air leakages through accidental holes or through open spaces between poorly connected sections of ductwork. Leaky supply duct cause the depressurization of the structure and outside air is forced in through crack in the envelope. Leaky return ducts cause pressurization, which forces conditioned air inside air out of the structure. Sealing both supply and return duct minimizes energy loss by infiltration. Next, good engineering practices for designing ductwork. Air distribution within the space is critical to maintaining space condition and minimizing noise concern. Here are some key guidelines for designing ductwork that should be followed to get the most out of your system. A. Configuration. Duct should be designed so that the length of each section of ductwork is short enough to provide proper control of airflow and stability of construction. Radial or trunk and branch configuration have shorter run and generally work best. Wherever possible, duct should be located within the conditioned space. Long main section of ductwork can lead to trouble, such as duct collapsing over time or becoming twisted and blocked. B. Go straight. This is the most important rule of all. From an energy perspective, air wants to go straight and will lose energy if you make it bend. From a cost perspective, straight duct cost less than fittings. Fittings are expensive because they must be hand-assembled even if the pieces are automatically cut by plasma cutter. So when laying out a system, try to reduce the number of bends and turns to an absolute minimum. Iwasan mo yung maraming elbow, lahat kahit sa piping. C. Make sure ducts are the correct size. Ductworks that's too small won't be able to carry enough air to heat or cool your building. Ducts that are too large can lose both air and energy during cutting system efficiency and wasting money. Use trusted industry standard and procedures such as those established by ASRE to size your duct. Ito yung mga procedure pag size ng ducting, hindi yung bara-bara, basta lagay ng size. Pag pinaandar na, hindi na lumalabig yung iba, o kaya di lumalabas ang hangin. Letter D, make sure there are enough return ducts. Supply ducts carry conditioned air to your building, but the system also requires enough return duct to bring expanded air back to the HVAC unit to be conditioned again. Each room that requires heating or cooling should have at least one return duct. As a rule of thumb, use 2 CFM for each square inch of return air opening. For example, 20 by 20 grills equals 400 square inch area of goal, which means 800 CFM of recommended airflow. E. Be careful when you install duct. Duct placed in conditioned space are more efficient than those placed in unconditioned spaces. If located within conditioned spaces, conductive and magnetic losses, leakage loss, and equipment cabinet loss are reduced or regained into the building space. If it is not feasible to locate ductwork within conditioned space, the duct should be properly sealed and insulated. The trunk ducts are usually located above corridors in the cavity above the ceiling to minimize noise transmission to the condition zone and allow easy access without disturbing the building occupant. Next step, thermal zoning. Zoning is a practice of dividing a building into distinct thermal zones, which have similar heating and cooling requirements. In practice, the corner rooms and the perimeter spaces of the building have variations in load as compared to interior core area. The buildings are usually divided into two major zones. The exterior zone. This is the area inward from the outside wall, usually 20 to 80 feet, if rooms do not line the outside wall. The exterior zone is directly affected by outer conditions during summer and winter and has variable thermal load. Next, interior zone. This is the area contained by the external zone. The interior zone is only slightly affected by outer conditions and usually has a uniform and steady cooling load throughout. For few areas, for example, conference and meeting rooms are influenced by variable occupancy load. The concept of thermal zone is important to size HVAC equipment and plan the way ducting is noted. If zones have a special temperature and or humidity requirement, these should be served by independent air distribution system, separate from variable zone. The idea is to permit pressure-independent control of temperature and humidity in similar zones. Where it is possible, consider use of VAV system and or supplementary control. G. Seal and insulate. Make sure all ductwork sections fit together tightly. Connection can be mechanical sealed with metal screw or other fastener to improve connection length. Seal connection with mastic or metal tape. Cover the ductwork with insulation such as rigid fiberboard or the standard blanket type insulation. S. Rule of thumb. The 10% rule. For supply duct longer than 10 feet, the air is reduced in that time by 10% for every 5 feet over 10 feet. For example, 30 feet tank gives a reduction of 40%, 30 minus 20 is 20, then divided by 5 for support times 10. Okay. Minimize length and restriction. Keep the supply duct length as close as to 10 feet as possible, but never less than 6 feet. Use the fewest number of vents as possible. So 24-inch rule. Use at least 24 inches of straight plenum before any fitting, such as an elbow. 24. T or takeoff. Electric tacketers require 48 inches. Avoid elbows directly off units. The maximum total plenum length should be restricted to 150 feet. For the plenum, maximize length and minimize restriction. 60-40 rule. When using a T, split the flow as close as to 50-50 as possible. No more than 60/40. Always use a turning blade. 70-30 rule. Turn the T 90 degrees to make a side branch with no more than 30% of the air. Do not use a turning blade. Turning blade. Takeoff. Maintain distance between takeoff as evenly as possible. Space the takeoff at least 6 inches apart and 12 inches from the aircraft. Fitting. Use long and radius duct fittings instead of short or mitered fitting. Long radius duct.